First of all, we're going to need a fully configured and synced Dappnode. This is kind of like what it should be looking like, this interface. We're probably going to put one of these together for setting this up, but the idea is to start off with fully configured Dappnode. So this is the first thing that you're going to need. And you're also going to need some validator keys, which we are going to be generating in this process. And for today's purposes, we're going to be setting up a validator in the Girly testnet. So we are going to need 32 Girly ETH, which we have. But yeah, like if you're looking to do this in mainnet or Gnosis chain or even Luxo in the next few months, just make sure that you have enough funds for making a deposit. So okay, in this case, we're going to be starting with the Ethereum.org Launchpad. This is a Launchpad for the Girly testnet, but it's pretty much identical to the one that is being used in mainnet. Also, like for example, if you are looking into depositing into Gnosis chain, they have like their own deposit front end. This is kind of like how the Gnosis chain Launchpad looks. It's pretty much the same. It's just like making submitting a deposit file. Let's stick with the Ethereum Launchpad for the purposes of this exercise. So, okay, we're going to click on Become a Validator. We're quickly going to be reviewing each of these steps. So first of all, proof of stake kind of like explains how the new consensus mechanism for Ethereum works and the importance of the role that validators have in this mechanism. So if we go to the next step, this deposit tab will give us a little bit more of information about what we were just talking about and how the process is for depositing, in this case, 32 the Girly testnet ETH into the Beacon chain. So it says that you'll be using the terminal. And yeah, at some point it might have been more accurate, but I'm very, very happy to say that this thing has improved a lot. So probably this is a little bit outdated because I don't think we're going to be using any terminal commands today. So yeah, this is why you want Dappnode, exactly. Uptime, we're going to be talking a little bit more about uptime. A very, very frequent, let's say, not only question, but fear of getting involved in your own validator is the fear of getting slashed. So we're going to be talking about this a little bit more in a minute, but there's a big, big difference between slashing and attestation leakage. So for offline time, you won't really get like a slash. You won't lose like half your ether. You'll be losing very few like weight units per attestation that you missed, but it pretty much takes the same amount of time that the validator node was offline just to get that balance back. So let's say that if you are offline for 6 hours, as soon as you start attestating again, it'll take you 6 hours to get back in the same balance before you had that attestation leakage. So it is very, very different from slashing.
It's more like half or between half and 2/3 of the time. So it's even faster. Yeah.
Yes. Bad validator behavior. This is what they mean about slashing. So I'll probably save this for when we are uploading the key stores to our Dappnode, because it'll just be clearer once we can show it to you.
We hear on bad behavior, like unless you're trying to do something, like unless you're trying to do bad behavior, it's really, really difficult. And we've designed Dappnode in order to avoid any potential misconfigurations or the keys being in two different places at the same time. So we've basically eliminated the possibility of any sort of accidental slashing. Just bear in mind that there is still the possibility that the validator software that you're using has a consensus bug and you end up with a slashing condition, but that's just inherent to everybody using the validator client that you're going to be choosing to use. I have to say that I have never seen anything like that. It hasn't existed anything like that, and nobody has been slashed by a consensus bug in the validator client. All of the slashes that I know of have been due to poor key management, which is exactly where we are right now. Thanks, Chewy.
Yes, so we're going to dive deeper into the key generation part, but you could say that that's pretty much like the only step where you really, really, really need to stop and just pay more attention to every step of the process, because, like if sometimes things don't go that well, but most of the time they do, but sometimes they don't. So as long as you have your keys properly stored, there's a solution to these kinds of issues most of the time. So make sure you really, really take care of the keys that we're going to be generating for our validator. Early adopter risks. I think this is also maybe a little bit outdated on the Ethereum Foundation side. So this is our checklist. We're also going to be going through it. We already have pretty much all of this because we have Dappnode, and pretty much the software takes care of handling these settings. But yeah, this is kind of like what you can see on the checklist. So let's go a few steps back and just keep going with the Launchpad's steps. So as I was saying, the first thing that you're going to need is fully synced Dappnode. So in my case, you can see that if I go to the stakers menu and I select, which is the early testnet, I already have chosen Girly Geth, Nimbus Prater. Always make sure you use Checksync. This way you can sync much, much faster, especially if you're running a validator. And the Web3 signer is going to be very, very important because this is pretty much the staking brain of Dappnode and takes care of feeding your key stores in a safe way to your consensus client. So this even brings lower the chances of things going wrong and having slashing penalties because of just like misconfiguration or something like that. So if we go to the dashboard, we can see that our clients are already synced. This might take you a few hours or days depending on your connection. But once you have your sync clients, you are good to go.
Let's go over the pieces that you need in order to stake. You need an execution client, which is what used to be like Ethereum 1, right? Then you need a consensus client, which is Ethereum 2. This is what's going to be, this is the beacon chain. This is the actual chain that you are validating when you run a validator. And then in theory, you're good with that. But we've added this Web3 signer on the side to manage the keys. We're using it as a key manager. And what this allows you to do is it allows you to leave the keys there and then change any consensus client just with one click. And you don't have to take care of taking the keys out of Prism, for example, and then putting them into Lighthouse. So this is a key aspect that a lot of people might be prone to make a mistake, because you have to eliminate the keys from Prism before you put them into Lighthouse, or you're going to have two keys validating at the same time, and then boom, slashing condition, you're out. So basically, we eliminate the possibility of not even like making that mistake at all, because the keys always will live here in the key manager UI. You see that button that says import? We're going to import them later down the tutorial. But yeah, really the important thing here is choose whatever combination of execution and consensus client you want. Here, there's an interesting concept. I'm sure some of you have heard of client diversity. And if we go back to the Stakers UI, voila, here we go, client diversity. You already had this prepared. Chewy, sorry. Maybe I'm getting ahead of myself. But yeah, here you can see what clients are the most used. And it's important to have client diversity because remember what I was talking about, a bug on the consensus layer client or on the execution layer, like a client implementing bug. Well, in Ethereum, there's one thing called correlated penalties. And the more nodes in the chain that do the same mistake at the same time, the bigger the penalty for those nodes that have the same mistake that are correlated will be. Moreover, if we have a client with a super majority, especially on the consensus side, then there's like pretty bad stuff that can happen if there is a bug in that client and this client creates a chain of its own, and because it has a super majority. But we're not on that stage right now. We still have a lot of dominance between Prism and Lighthouse. So I would recommend you to choose Lodestar or Nimbus or Teku. But actually, for you as a user, it doesn't matter which one you use. So feel free to choose the one that you like the most. One warning about the execution clients. Aragon. Aragon is a full, or what used to be called an archive node. It's a lot heavier than the other ones. Do not install Aragon if you only have 2 terabytes in your machine. You can install any other, Geth, Nethermind, Besu, but do not install Aragon if you have 2 terabytes, a 2 terabyte disk. Only do it if you have a 4 terabytes disk or like a gigantic disk. Okay, it's good because it's a lot more complete in terms of the information that you can get. And if you can run Otherscan, for example, which is a local block explorer. Imagine having Etherscan but run locally. You can actually do that, and you can do it with Aragon and a community package that's in the public tab store called Otherscan. Now, nothing more about the choices that you need to take here on execution consensus. Basically, the long story short is it doesn't matter what combination you use. It is recommended to use minority clients, both in the consensus and execution client, and do not use Aragon if you have a small disk. Those are the 3 points that you need to remember.
At a user level, as Paul was saying, is pretty much the same. So don't be afraid to make a wrong choice at this point. It's just part of the experimentation, you know. And the cool thing is that you can also easily switch. Well, at least the consensus clients. And as I was saying, as long as you use Checksync, you should be able to, let's say, like switch to Lodestar at this moment. And I'll just use Checksync. I won't do it right now because I don't know how long it's going to take, but it usually takes less than 10 minutes. But for the purposes of moving forward with this tutorial, I'll just leave it with Nimbus at the moment. So are there any questions so far?
Maybe one last thing that you can explain. One last thing that you can explain is MEV Boost. We haven't really talked about MEV Boost, which is like the last choice that is in here. And yeah.
Okay, so as part of the Dappnode stakers menu, you can easily pick which relays you want to run for MEV Boost. So if you selected, I don't know, I'll check like Flashbots, let's say. If I go here and apply changes, this is pretty much like everything you need to do to run MEV Boost.
Very quickly, just to bring everybody into the same page, because MEV Boost, first of all, it is optional. You are going to be validating just with execution, consensus, and remote signer. You don't need MEV Boost. But MEV Boost will give you access to MEV opportunities. What are MEV opportunities? Well, as you've heard, there's people that are sandwiching other people, and they're doing some sort of attacks. And in order to do these attacks, they need to bribe the person that is creating the block to introduce certain type of transactions, these sandwich transactions, right? And they will do that. But since they cannot find you, a solo staker, they cannot find you in the middle of like the entire source of validators. They have created, well, the company Flashbots have created this sort of marketplace where you as a user, if you are the selected block producer, the next block producer, you can go to one of these relays that you can see here, Flashbox, Blockthread, Block Native, Internet, or Manifold. You can go there and say, hey, is anybody trying to extract value here? Can anybody bribe me so I will get more revenue from that block. And if the answer is positive, instead of you building your own block, and when I say you, I mean your consensus, your validator client, et cetera, instead of you building your block, you will get your block from somebody that has built this block for you, and they have built it as they want. They have built this block with the rules that they want. They maybe they didn't put any transactions. You don't know what they put. You're basically going to put your signature in a block that you will not be able to see. But the only thing that you'll be able to see is what they will pay you. Now, what they will pay you is usually higher than what you could do with a normal block. So you get extra revenue coming from MEV. Now, there's ethical concerns about MEV. There's ethical concerns, and also there is, you see here, OFAC. So when you build blocks, there's some of these relayers do not accept blocks that include transactions with tokens that are sanctioned by the OFAC, by the United States. And this is only what it means, this field over here. If we go to here, since it's testnet, it's not marked. But if you go to mainnet, if you're doing this on mainnet, you will see whether it's OFAC compliant or not. If there's a yes, it means that it's OFAC compliant, meaning that you will not have transactions that have to do with the Torn token or with Tornado Cash. That also means that you will be contributing to censorship in the Ethereum network. Let's be very clear. You will be contributing to censorship. You will effectively be blocking anybody freely transacting with tokens, with certain specific tokens, and you will be complying to the request of the United States to censor these blocks and do not include this. Now, if you live in the United States, you might prefer to be safe. I personally think it's over compliance to do that, but hey, feel free to do what you want. Any questions about MEV Boost? Yes, forgot to mention the default fee recipient and what it is compared to the validator withdrawal address. That is a very good question. Thank you so much. So you will see default fee recipient up here at the top. And this default fee recipient is just a sort of the default address where your validators will be sending fees every time they propose a block. As you know, there's two types of revenue when you propose a block. You're a validator because you want to propose blocks, right? So when you propose a block, there is the consensus reward. That's what you would get from mining, what the old mining is. That's just because you have been tasked to create a block and you have created, you will get some ETH. And this is also known as inflation reward. This is what the ETH that is created at every block. This is new ETH. It has never existed before and it will be created. There's a second type of reward that you will get, which is the transaction fees that we all pay. And they used to be called transaction fees. Now they're called tips because we're burning most of the transaction fees after EIP 1559. But we still don't give tips to the block producers. And those tips, you will actually get them yourself. They will go to your address. And it says default fee recipient because by default, all the fee, when you propose a block, the fees from execution will go here. But there is a more granular way of doing it on the Web3 signer or the staking brain. If you go, we will see it when we upload the key stores, but you can choose by keys. If you have more than one key, you can choose to send the rewards of each of the validators that you are running to different execution layer addresses. I hope that explains your question, Santiago.
Oh, and one more thing about MEV Boost. If you already have a Dappnode or validator and are interested in running MEV Boost, just make sure you have access to very, very fast internet connection, because sometimes we've seen that while your client tries to talk to one of these relays, sometimes people can miss a block, especially if they have a lot of relays selected. So just keep that in mind if you're interested in running MEV Boost. So, okay, let's go back to the Launchpad. Today we're going to be running just one validator. The withdrawal address is The first kinds of rewards that you were just mentioning, it's pretty much where, number one, you're going to be getting all of the inflation rewards that you generate from your validator node. So every time that new ETH is given to you because of the block that you proposed, this is the address where that will be showing up. And also, in case you want to stop validating one day for any reason, this is the address where you're going to be receiving your 32 ETH or whatever funds you have deposited in whatever chain. So it is very, very important that you keep this address in a safe place, because once you set it, you cannot change it. So make sure you have good security practices around this address that you'll be using.
That's right. Yeah. One more time. The fee recipient address is where the execution layer rewards will be. So that's the tips that people doing the transaction fees that will go. Now, you will be accumulating ETH, the inflation ETH, the consensus layer ETH. You'll be accumulating, and periodically, the beacon chain will be sending this not to the fee recipient address, but to the withdrawal address, right? So you will also receive ETH in the withdrawal address, but this ETH will be the one that you the one that is created by you doing the attestation duties, doing the sync committee duties, and of course the block proposal duties that you have as a validator. They can be the same. They can be the same. There's no problem if they are the same, but they are used in different ways. One is where you will receive the tips and transaction fees. That's the fee recipient address. And the other one is where you will receive the ETH that is in the consensus layer. If you lose access to the withdrawal address, you will never be able to recover your ETH. This is very important.
Please don't.
To remember. Use a hardware wallet, use something that make sure that you have a backup of this key, make sure that you can access this, make it into a multisig. It is completely fine if this is a multisig. Have a multisig as your withdrawal address. You can receive your ETH there, and then you have different ways of recovering it. But please, it's extremely important, make sure that this is safe, okay?
Our current operating system, we're going to be selecting Linux because Dappnode is based on the Linux distribution Debian, in case you are a Linux fan. And if not, you just need to know that we are using Linux. That's fine. How do we want to generate our key? So this is, when we first opened the Launchpad, this is what I was referring to when I talked about not using terminals. Today, we're going to be using the wagyu keygen tool developed by Stakehouse. There are two files that you need to generate. So we're going to open wagyu. And here is where we're going to be picking the Girly network for today's exercise. We're going to create a new secret recovery phrase.
One thing on the network, there is a community maintained fork of wagyu that will also work for Gnosis chain. So if you are thinking of validating on Gnosis chain, pretty much everything that we have said is valid. You will need to use this other community fork of wagyu. I can, if you ask for it in the chat, I will be looking for the link and I can send it to you. And then make sure that you use the right network on the Gnosis one in that case.
Oh, and by the way, Luxo just released their own fork of wagyu recently. So if in the near future you're going to be validating in Luxo, you're also going to come across this amazing tool that saves you the steps around terminal. So let's create the new secret recovery phrase. And again, you are going to be able to see the secret recovery phrase here because of demonstration purposes, but these are not the keys that we're going to be using today. I previously generated another extra pair of keys, but for the purposes of this exercise, we're going to be using this.
Again, Here we're like, let's remind people how they should be doing this. So ideally, you have downloaded Wagyu for your machine, or even there's the possibility that you have a secondary machine, like an old machine and a Linux, and that has never had access to the internet, for example, and you install Wagyu in there with a USB key, and you generate the keys on that computer without internet, and then with the USB key you take them back to your main computer where you're doing all of this, where you have your MetaMask, etc., and where the computer that you'll use to do to connect to Dappnode and put the keys, etc. Now I have to say this because the best practice that you can do, I need to tell you that the best practice that you can do is to use a computer that doesn't even have a Wi-Fi card, that does not have the possibility to be connected to the internet. Is that overkill? Some people say so, but that's the safest that you can go. Is it safe to download these in your computer, reset your computer without internet, create the keys, save the keys somewhere, and then restart your computer so you clear the cache and you clear everything, and then you connect to the internet? Yes, this is safe enough. This is considered safe enough. So you don't need a second computer to do this. But when we're dealing with these keys, we need to be very, very paranoid, okay? Because they basically have access to 32 ETH at the very minimum. If you generate more than one validator, then they will have more. So please be safe with that. Now, you're seeing right now all of these 24 words. These 24 words, please do not copy and paste them and just have them in your clipboard for copy pasting information. These stores these words in a place. I'm being extremely paranoid, but of course I don't want you to go and say, hey, Lensky told me to do it like this and now I'm fucked. No, probably you're going to be fine. Probably you're going to be totally fine. But the safest way to doing is you look at this, you write them in paper. You write them in paper in a place, and you ideally you have a plan for this paper to keep this paper extremely safe. Okay, and you actually make 2 copies of this, and you leave one in another house just in case there's a water accident and this paper gets damaged. So voila, you copy those, and then you manually copy them on the next page. Here, you would manually copy them here from the thing. Okay, this is the safest you can do. You can copy and paste. Yes, you can, but remember that you need to have this mnemonic written somewhere. You will need to write down this mnemonic somewhere. Okay, have it somewhere. Do not forget to write this mnemonic somewhere and keep it real safe.
And also, if we're being extremely paranoid, I personally wouldn't even copy the seed phrase into the clipboard, because the clipboard sometimes is also risky depending on the ecosystem where you're using it. So if you're going to be 100% safe and be extremely paranoid about your 32 ETH, you're going to get a separate computer that does not have access to the internet. You're going to be manually copying each word of your 24-word seed phrase. And also you're going to be putting it back manually instead of using the clipboard, just to be 110% safe. Let's create a temporary password.
Put your withdrawal address. It's extremely important that you do put your withdrawal address. Otherwise, there is a tool to put it afterwards, but it's a little bit messy. It's a little bit messy, and you'll be a lot better off. There's a tutorial on how to do it. So if you have left it empty, you're fine. You can recover. Well, you can recover it. You can choose to put the withdrawal address. But if you do it from the beginning, from the get-go, all the better. A lot safer. You're generating the keys already with the withdrawal address as a key that you control. Otherwise, you open up yourself to the fact that somebody might have the possibility of changing this to their own address, because it can only be changed one, and then you cannot recover it. You know what? Just put it here and generate your key stores already with the withdrawal address that you want.
this step is pretty important. Make sure you pick a safe place. Some people use like some kind of like cloud service. Some people use like a USB thumb drive. So again, it depends on the preference of security practices on the user. But yeah, just make sure to keep these, because let's say that there's like some kind of, I don't know, like earthquake or flood or whatever, and then your Dappnode hardware is gone. It's unfixable and your key stores were there. If you backed up your key stores correctly, you just need another configured and synced Dappnode, and then you can re-upload your key stores. And as long as you're 100% sure that you don't have the same key stores uploading two different Dappnodes, you'll be good.
So here again, Chuy says Chuy is the good cop and I'm the bad cop, and I come here to put fear into your veins. So in this case, basically what these key stores are, like, I actually do the opposite here. They're not that important. Why? Because you have saved that mnemonic, right? The mnemonic, so you can basically regenerate those key stores from wherever you want. As long as you have the mnemonic, you can regenerate these key stores. It's deterministic. So if you have the same mnemonic, you can regenerate these key stores. So it's like definitely like keep them extra safe and do not rely only on your validator, because if something happens to this Dappnode. Now, in that case, do not think that because your Dappnode is down or you don't know what's happening to your Dappnode, you can upload those keys somewhere else. Be very careful, because as Chuy said, if you have these keys validating in two places at the same time and that both places are online, you will get slashed, because you cannot submit two different blocks when you're supposed to validate a block. This is a slashing condition. So on the topic of backups, I think this is a good moment to talk about backups. People are like, oh, but it's good for high availability to have another Dappnode prepared to jump in. Don't do it. This is how people get slashed. I have seen people getting slashed because they had a backup setup. Again, the inactivity leak is very, very small. If you're off, I know people that were on holidays for a month, and on the first day of the holidays, their Dappnode went down. There was a storm, and the Dappnode went down. They were on holidays for an entire month, and after 2 weeks, after they got home, they were at the same level as they were before. So it's not that important. As soon as you can fix it, you will fix it. And if you get slashed, it's a lot worse. You will get slashed a lot more money. So don't be slashed. Don't worry don't spend money, because also if you have a validator, like a backup setup, that's also more money, you're further away from the break even, and you're in a more risky position. So just don't do it. Make sure that you have your mnemonic kept safe. Make sure you have the validator key stores. But yeah, definitely do not have a backup setup.
Okay, so once we generated our keys, we're going to go to the next step, where we're going to need our deposit data file. So I had previously uploaded one just for testing, but I just got rid of it, and we're going to re-upload the one that we're going to be actually using for our deposit. So before I proceed, what's the difference between these two files? So this is very easy. The deposit file will be basically requesting the beacon chain to open a new validator contract. And this validator contract will have information about where you're going to be withdrawing in the execution layer once the validator wants to exit, and this kind of information. So once the deposit is done, let's just go ahead and do it. The deposit file that I prepared here, and I'm going to click on continue. So this Launchpad, the cool thing is that it can automatically connect to your MetaMask. And so the Launchpad is going to tell us that we are in the right network and that we have enough balance to make a deposit. So yeah, as we've said multiple times, make 100% sure that you control this withdrawal address before depositing, as this cannot be changed. So we're gonna go ahead, continue, and the Launchpad is gonna make us go through these extra options and risks. Take your time. It's always a great idea to double, if not triple check that you are aware of these risks and this information that you'll need to know to not lose your funds. It's gonna ask us for deposit, and yeah, let's just deposit 32 girly ETH. So, as I said, it's always a great idea to double, if not triple check that everything is right. We're gonna go with the market gas. We're gonna click. Does anyone have any questions until this point? So this is pretty much what you'll see at this point, and this is where we go back into our Dappnode. And here, there's only one thing left to do pretty much, and that is uploading our key stores file. So let's say that we were saying that the deposit file and your actual deposit will open a new validator contract in the Beacon chain. But how do you know that that contract is actually yours? So what the key store file does is to claim this validator contract for you. So the way it does this is, let's go into the staking bring UI. And here we're going to click on import. Since this is the first time I'm uploading these key stores, the slashing protection data isn't necessary. However, let's say that I upload the key store here, and that for some reason, like, I don't know, maybe this Dappnode is like malfunctioning or something like that. If I want to take this key store off this Web3 signer, it'll give me the option to download slashing protection data. So the next time I want to re-upload this key store to another Dappnode or wherever I want to do so, I'll make sure I include this slashing protection data so that it minimizes the risk of being slashed. So I'm gonna input the password, and this is really cool from the staking brain, that you can actually select if you're a solo staker or if you are doing this key upload through an LSD or DVT network. So we're gonna go solo, and I'm gonna input my fee recipient address again. And if I submit the key stores, we'll see this success message, and here we go. This is our public key for our validator. Actually, if I select this and I click on this link, the thing is that this deposit was made 5 minutes ago, and there's actually like a line to be able to submit a new validator as well as exiting. However, if you go here, you can already see like the address where the deposit was made from, where the withdrawal credentials are pointing to. Let's go to any other validator that is working in the Girly Beacon chain at the moment, and we'll be able to see here. Let's go to this proposer. Okay, so this is what the actual validator looks like once it's up and running. And you can see, yeah, like information about the daily income, about the block proposals that you've been submitting, blocks, attestations, deposit. Actually, this validator hasn't set their withdrawal address yet. So this is why you see this. But since we set it when we were setting up the keys, once the validator goes active, you should be able to see a withdrawal credential already set up. This is
That's it.
pretty much it. Yeah.
Wow.
This is how you set up validator. And yeah, I don't know, like, are there any questions? Let me check.
So it takes basically less than an hour to do the entire process. It's pretty good. Yeah, I'm pretty good. Let's do a quick recap. So what is the first thing that we should do? Step one, set up everything on your side, right? Like set up your execution layer and consensus layer. Boom. Step one, done. Let this sync. You will not be validating unless your nodes are synced. So voila, step one, set up all the software that you need. Okay, good. Step two, what is the step two? So generating keys with Wagyu. Yeah, highly recommended that you use Wagyu. Don't use command line. I mean, you can if you know what you're doing, but Wagyu is a perfectly fine and acceptable and beautiful tool that came out of the ETH stakers community. You need nothing else but this. Remember to keep your mnemonic safe. Step three.
Step 3, make your actual deposit.
This is what generates the most panic.
So make sure you already went through the checklist, that you have your mnemonic saved properly. And once you have everything else and you're 100% sure that you're ready to proceed, you will upload your deposit file here, which will request a deposit of 32 ETH in the case of the Ethereum mainnet, or 1 GNO token in the case of Gnosis Chain, or 32 Lix tokens in the case of Luxo. So whatever minimum you need to deposit, this is the step where you'll be actually doing so. Last step, upload your key stores to your Dappnode's staking brain. You click on import. If it's the first time, you don't need to import any slashing protection data. And yeah, voila, there you go. This should get you a validator up and running in a few hours or days, or depending on how much it takes.
Beautiful.
I really like Gnosis Chain. Like it takes, I think, like 4 hours to enter, or sometimes even less. So in case you're trying to validate in the Gnosis Chain, it'll take you significantly less time compared to Ethereum networks. And
question, Chewy.
Yeah.
Can I validate in Ethereum and Gnosis Chain in the same Dappnode?
That's a great question. It depends. Like mostly it depends on performance, on your hardware's performance. It needs to keep up with synchronization for both blockchains. So in this case, I have 3 synced blockchains. We have Ethereum mainnet, we have Girly, and we also have Gnosis Chain. I have a total of 4 terabytes, and I'm using a little bit more than half, although I have some other stuff here. And memory has been working okay. Yeah, like I think a couple of updates of Nethermind ago, like they really brought down how much memory they were using. So this gave me a little bit of room to also install Girly node. And it has been performing very well, although I know I'm walking like a very thin line here. So I just got to keep this in mind whenever I have to like switch clients or stuff like that, so that it doesn't take a lot of the specs that I'm currently using to keep my validators up. But yeah, it's a matter of how much you'd like to experiment and how far you want to take your hardware's capabilities. But yes, the short answer is yes, you can be synced and validating in multiple blockchains.
All right, there's a question from Horacio saying how to do this with Rocket Pool. And I think the package is pretty self-explanatory. Basically, what you need is you need to have your execution and consensus layer and Web3 signer installed. You need to have execution layer, consensus layer, Web3 signer installed. Then you go to the Dapp store, you install the Rocket Pool package, and then you follow the instructions.
Second machine as backup. Any recommendations? The actual recommendation, as Paul was mentioning, is to not have a backup hardware. Sometimes this is a little bit unpredictable, and if you happen to run both of these Dapp nodes by accident, and you have your key stores uploaded to both of these, you will get slashed. So it is not recommended. The attestation leakage penalties are not as bad. Like you will get back on your feet after, depending on how much offline time you have. You just need a little bit less of that in online time to make up for that. But if you get slashed, there's no going back. So yeah, I think it's better to try to like optimize how your current Dappnode is running. And yeah, in case there's anything wrong, an attestation leakage will always be much better than actually getting actually slashed. And Nagamot is asking, how do I get back my 32 ETH I stake? In other words, close down my staking. Yes, that's actually a really good question. We did not go over that. So Dappnode makes it super simple. You're going to go to your staking brain, and then you're going to select the validator that you would like to exit, and you're going to click on exit validator. It's going to ask you for a confirmation, so you will actually need to type in I want to exit before it enables the button that will send the request to the beacon chain.
Yep. So one prerequisite for this would be definitely make sure that your withdrawal address is set before you do that step. And voila, as long as it's set, you just click here, say I want to exit, and then your transaction will be submitted. What's going to happen after this is that your transaction will go to the beacon chain, and the beacon chain needs a few hours to submit this queue. There's a limited amount of validators that can exit the validator set per slot or per epoch. I'm not sure. So there's also, just like there's an entry queue, there's also an exit queue. So the exit will not be immediate. It will not be immediately that you'll receive your ETH in your withdrawal address, but it will not take long. The queue is a lot shorter. How did you navigate to the staking brain in Dappnode? That's a great question, and you do it from the Stakers UI. Joey, if you can go over it once more.
So let's say that I'm in my Dappnode dashboard, so I'm going to go to packages, and then I'm going to select the Web3 signer package that I'd like to access. So in this case, it's Spreader, and you have the UI link here. So in the package, under UI, and it should take you directly to the staking brain. And also, let's say that I want to enter like another staking brain, you should be able to notice the difference because it'll say like right next to the name. So just so that you don't get mixed up with any other blockchains that you're validating for. Okay, Horacio is asking, can I have, for example, one validator, solo staking, and a couple of mini pools and rocket pool at the same machine? Absolutely, you can. Let's say that I upload, let's say that I'm going to upload the one that I just made for this exercise. And in here, I'm going to select, let's say, rocket pool. So the fee recipient will be set automatically for this. And I'm going to disable slashing data. And there we go. So once we take it back to the staking brain, you can see the icon is different here because this key store will be for a rocket pool mini pool, while this one is for solo staking. So you can have different protocols working, and yeah, they can all be working in this at the same time with the staking brain, which will always make it much safer to migrate your consensus client.